Algorithmic fairness has become a crucial concern in artificial intelligence research, but its development is not an objective process. Fairness is a subjective concept shaped by the values, experiences, and identities of those involved in research and development. A meta-analysis of 139 papers from AIES and FAccT conferences between 2018 and 2022 reveals two concerning trends. A US-centric perspective dominates fairness research, and fairness studies exhibit a widespread reliance on binary codifications of human identity. Current research often overlooks the complexities of identity and lived experiences, failing to represent diverse global contexts when defining algorithmic bias and fairness. The development of fair AI systems is not a universal, abstract concept, but is deeply intertwined with the values, experiences, and identities of those involved in the research process. A comprehensive understanding of fairness necessitates a conscious effort to acknowledge and understand the values embedded in the research process itself. The meta-analysis builds upon a growing body of research surveying and critiquing the fields of AI ethics and algorithmic fairness, highlighting geographic bias in authorship and definitions of sensitive attributes. Previous studies have shown that AI ethics research often exhibits a bias toward countries in the global north, presenting their cultural perspectives and values as universal and globally fungible. The findings of this study underscore the need for a paradigm shift in fairness research, embracing a more nuanced and contextual understanding of human values. The research community must support the development of genuinely representative, inclusive, and fair AI systems. This requires acknowledging and addressing the limitations of current research design choices, including the reliance on binary formulations for sensitive attributes and the dominance of Western-centric values and perspectives. This study examines the practices of problem selection and formulation within algorithmic fairness research, employing a meta-analysis methodology. It investigates geographic and cultural biases, as well as implicit norms affecting diversity and representativeness in the research process. The analysis focuses on papers from the AAAI-ACM Conference on Artificial Intelligence, Ethics, and Society and the ACM Conference on Fairness, Accountability, and Transparency from 2018 to 2022. The study documents dataset characteristics, author information, and modeling choices, including the use of proxies, intersectionality, and fairness metrics. It also assesses the degree of acknowledgement and mitigation of limitations related to these design choices. The findings aim to inform future best practices in fairness research, highlighting novel ideas, significant findings, and important arguments presented in the papers. The research paper examines norms in fairness research through a meta-analysis of 139 papers from AIES and FAccT conferences. It focuses on dataset provenance, author information, model design decisions, and sensitive attributes. The authors document country affiliations for authors and datasets, noting the US dominates both. They also analyze model design decisions, including fairness metrics and mitigation methods. The study finds that retrospective studies are the majority, with finance being the most popular dataset domain. Regarding sensitive attributes, gender, race, and age are the top categories. The paper emphasizes the importance of socio-technical analysis to understand the complex interplay between technological systems, human actors, and their broader societal context. It concludes by highlighting the need for careful consideration of social constructs in future research. This meta-analysis examines the norms and biases in fairness research, focusing on the geographical, cultural, and implicit norms that shape algorithmic fairness studies. The analysis reveals a substantial variation in labels assigned to sensitive attributes, such as race, age, and gender, even when papers rely on the same dataset. For instance, race labels included Black, African American, White, Caucasian, and Asian, South Asian, East Asian, Pacific Islander, while age labels exhibited inconsistencies in cutoff points and categorizations. Most papers, 89.7%, failed to provide definitions for sensitive attribute labels, with age being the most problematic, where 20.6% of studies investigating age neglected to define the age ranges used. Additionally, papers often omitted information regarding the source of their labels, rarely clarifying whether the labels originated from third-party observation or self-disclosure. The socio-technical analysis highlights two striking patterns: a disproportionate bias toward the U.S. in both author affiliations and dataset origin, and a pervasive tendency towards binary formulations of sensitive attributes. The analysis reveals that 80.6% of papers published each year feature at least one US BASED author, and that the US also dominates dataset provenance, 72.6%. This US centrism raises concerns about the limits of global fungibility, as papers rarely acknowledged or addressed potential biases arising from the predominance of the US in author affiliations and dataset origins. The study emphasizes the need to consider the unstated influences shaping algorithmic fairness research, including geographical, cultural, and implicit norms within the research community. These biases can affect the diversity and representativeness of conducted studies, ultimately influencing the technological outcomes of algorithmic fairness research. Here is a combined summary of pages 9 and 10. The authors conduct a meta-analysis of fairness research, focusing on the formulations of sensitive attributes used in various studies. The analysis reveals a prevalence of binary formulations, particularly in gender, race, and age. The Sankey diagram in Figure 4 illustrates the distribution of label formulations for these attributes across fairness studies. For gender, the most common formulation is the female, male, binary, used in 41 studies. Race is predominantly formulated as black, white, or African American, non-African American, with 15 and 5 studies, respectively, employing these formulations. Age exhibits more diversity in categorization, but still tends towards binary formulations, such as 024 and 25+, or 064 and 65+. Figure 5 provides a more detailed examination of binary formulations for sensitive attributes, specifically highlighting the most frequently studied attributes: gender, race, and age. The diagram shows that 41 studies formulated gender as female, male, while 15 studies used the black, white binary for race. Age was most often categorized as 024 and 25+, or 064 and 65+, with 3 studies employing each of these formulations. The analysis raises important questions about the assumptions and limitations underlying fairness research, particularly in the context of sensitive attributes. The prevalence of binary formulations may oversimplify complex social realities, potentially leading to biased or unfair outcomes. The author's findings underscore the need for more nuanced and diverse categorizations of sensitive attributes in fairness research. The research paper under analysis examines the biases and limitations in algorithmic fairness research, particularly in the context of US-centric norms and binary formulations of sensitive attributes. It highlights how the field's outputs are influenced by American societal structures and legal frameworks, often at the expense of other cultural and social contexts. The paper argues that the use of binary labels, such as race and age, oversimplifies complex social identities and ignores the nuances within these categories. This approach not only erases intersectional realities but also positions groups against each other, rather than as collaborators against systems of oppression. The study emphasizes the need for more nuanced and context-specific approaches to fairness, acknowledging the fluidity and complexity of identity. It also stresses the importance of recognizing the historical and ongoing impact of US-centric biases in research design, data origins, and the definition of demographic categories. The authors suggest that a more inclusive and equitable research framework is necessary to address the diverse experiences of discrimination and promote truly fair systems. Here is a combined summary of pages 13 and 14 of the research paper. The paper critiques the current state of fairness research, arguing that it is limited by US centrism and binary logic. The authors contend that these frameworks restrict the scope of inquiry and exclude alternative perspectives, leading to a myth of algorithmic fairness as a fungible, abstract, and universal phenomenon. To move beyond this myth, the authors propose that the fairness research community must chart new paths forward, guided by the principles of inclusivity, representativeness, and cultural specificity. The authors suggest that expanding the scope of inquiry to other sites of study, such as generalist conference venues, preprint repositories, and journals, will help enrich and contextualize our understanding of contemporary norms and practices in fairness research. They also advocate for a critical examination of the social and structural factors shaping research practices across these sites to identify biases and encourage a more inclusive and representative vision of algorithmic fairness. Several solutions are proposed to address these limitations, including prioritizing transparency and self-reflection, diversifying representation across datasets and research teams, and grounding research in real-world issues. The authors emphasize the need to move beyond simplistic binary classifications and engage with the complex, intersectional realities of bias, identity, and community. The paper's meta-analysis reveals a field grappling with fundamental tensions, including the tendency to default to US-centric perspectives and binary representations of sensitive attributes. The authors argue that these limitations can compromise the credibility of research insights and lead to policy solutions that are poorly aligned with the needs of diverse communities. The authors position themselves as situated at the intersection of technology and marginalized communities, with research backgrounds in algorithmic fairness, human-computer interaction, and critical algorithmic studies. They acknowledge the potential biases introduced by their own identities and experiences and welcome constructive engagement and alternative perspectives to challenge and enrich their understanding. The research paper discusses the concept of unfair norms in fairness research, focusing on the meta-analysis of various studies. It highlights the importance of understanding the biases and disparities present in AI systems, particularly in the context of gender and racial identity. The authors emphasize the need for a more nuanced approach to fairness, considering the intersectional nature of biases. They also stress the importance of participatory AI, ensuring that the development and deployment of AI systems involve and benefit diverse groups. The paper references several key studies and theories, including critical race theory, data feminism, and socio-technical design principles, to support its arguments. It concludes by emphasizing the urgent need for a more equitable and inclusive approach to AI development, acknowledging the limitations of current methods and highlighting areas for future research. The paper explores the concept of fairness in machine learning research, focusing on how norms are often unfairly applied across different contexts. It delves into the intersection of race, gender, and technology, highlighting the need for a more nuanced understanding of these complex relationships. The authors begin by discussing the importance of considering societal norms and cultural context in fairness research, citing examples such as the concept of whiteness as property, Harris, 1993, and the role of metaphysics in shaping psychological mechanisms, Hochstein, 2019. They emphasize the significance of subverting machines and fluctuating identities, Liu, K., and McKee, 2022, and the importance of global perspectives in algorithmic fairness, Sambasivan et al., 2021. The study also delves into the concept of informational fairness, examining how explanations can impact perceptions of fairness and trustworthiness in automated decision-making processes, Schofer, Cole, and Machowski, 2022. It further highlights the role of abstraction in socio-technical systems, emphasizing the need for fairness and abstraction to be considered together, Selb et al., 2019. Moreover, the paper discusses the importance of considering cultural norms in AI research, emphasizing that Western, educated, industrialized, rich, and democratic, weird, societies should not be treated as the norm. Septiandri et al., 2023. It also explores the relationship between race, gender, and technology, citing examples such as the impact of societal context on children's independent mobility, Malone and Rudner, 2011, and the significance of transsexuality in discussions of femininity, Serrano, 2016. The authors also address the limitations of current data-driven approaches, noting that datasets are often reduced, reused, and recycled without proper consideration for their cultural and societal implications, Koch et al., 2020. They emphasize the need for critical data studies, Iliadis and Russo, 2016, and the importance of understanding the cultural context of data collection and analysis, Marabi et al., 2021. Finally, the paper touches upon the role of fairness in pensions and social policy, referencing the work of the Organization for Economic Cooperation and Development, OECD, 2009, 2021. It concludes by highlighting the need for a more nuanced understanding of fairness in machine learning research, one that takes into account societal norms, cultural context, and the complexities of race, gender, and technology. This meta-analysis examines the norms in fairness research, focusing on the geographic distribution of authorship affiliations, study design, and algorithmic interventions. The authors conduct a comprehensive review of existing literature, citing 14 papers that investigate fairness in machine learning, including those that address intersectional feminist and participatory approaches, hysteria in the history of mental health, and fairness for unobserved characteristics. The geographic distribution of authorship affiliations over time, as depicted in Figure 6, reveals that the United States consistently contributes the largest share of affiliations across all years. The study design of fairness research papers is categorized into 3 methods: prospective, retrospective, and theoretical. The results show that retrospective analyses, which involve empirical simulations with existing datasets, are the most frequently used approach to study algorithmic fairness, Figure 7a. Additionally, there is a notable shift towards using synthetic data after 2018, with non-synthetic datasets focusing on applications within financial and criminal justice contexts, Figure 7b. In terms of algorithmic interventions, the results indicate a clear preference for in-processing interventions, which directly modify the algorithm during the learning process, Figure 8a. These approaches tend to overshadow pre-processing interventions, which focus on data adjustments before training, and post-processing interventions, which address fairness concerns by modifying algorithmic outputs. The analysis also reveals a growing ambiguity regarding the inherent trade-off between fairness and performance, Figure 8b. Overall, this meta-analysis provides a comprehensive understanding of the norms in fairness research, highlighting the need for more diverse authorship affiliations, varied study designs, and innovative algorithmic interventions to address fairness concerns in machine learning. Here is a combined summary of the 2 pages. The prevalence of study types and datasets in fairness research is examined through a meta-analysis. Figure 7 illustrates the trend, showing that the majority of fairness papers engage in retrospective analysis of existing datasets and algorithms, with synthetic datasets being the most frequently leveraged. The Compass dataset is the most studied individual dataset, followed by the German Credit and UCI adult datasets. Figure 8 highlights the trends in intervention points and acknowledgement of performance trade-offs over time. In-processing consistently emerges as the most common point for implementing fairness interventions, with the exception of 2020. Notably, there is an upward trend in the number of papers that do not address whether improving fairness metrics comes at the cost of performance. The paper also investigates the prevalence of different fairness metrics in the sample over time. Figures 9 and 10 illustrate the results, presenting the top 10 most frequently used metrics and the full list, respectively. A single study might explore multiple metrics, such as demographic parity and equalized false positive rates across demographic groups. Figure 9 depicts the 10 most common fairness metrics from the sample, demonstrating that demographic parity consistently ranks high in popularity over the years. These findings suggest that there is a lack of diversity in the datasets and fairness metrics used in fairness research, with a small subset of metrics and datasets dominating the literature. This meta-analysis highlights the need for more comprehensive and diverse approaches to fairness research, including the exploration of alternative datasets and fairness metrics. Furthermore, the lack of acknowledgement of performance trade-offs in many studies underscores the importance of considering the potential trade-offs between fairness and performance in algorithmic decision-making systems. Here is the combined summary. The authors conduct a meta-analysis to investigate the prevalence of fairness metrics in research papers, highlighting the concept of unfair norms in fairness research. Figure 10 presents a bar plot illustrating the usage of fairness metrics across papers in the sampled dataset, showcasing a temporal trend in the adoption of these metrics. The plot reveals that certain fairness metrics, such as demographic parity and equalized odds, have gained popularity over time, while others, like statistical parity, have experienced a decline. The sampled papers, listed in tables 2 and 3, comprise the full dataset reviewed for this meta-analysis. These tables provide a comprehensive overview of the papers selected, enabling a deeper understanding of the research landscape in fairness metrics. The author's analysis of these papers aims to uncover patterns and biases in the adoption of fairness metrics, ultimately shedding light on the unfair norms that may be perpetuated in fairness research. Through this meta-analysis, the authors seek to identify the most widely used fairness metrics, as well as those that are underutilized or overlooked. By examining the temporal trends in fairness metric adoption, the authors can infer the research community's evolving understanding of fairness and its operationalization in various contexts. The sampled papers serve as a representative dataset, allowing the authors to draw generalizable conclusions about the state of fairness research and its underlying norms. By scrutinizing the prevalence and trends of fairness metrics, the authors can uncover potential biases and limitations in the current fairness research paradigm, ultimately informing the development of more comprehensive and nuanced fairness metrics. The meta-analysis provides a critical examination of the research landscape, highlighting areas for improvement and opportunities for future work in fairness research. The research presented in these pages focuses on various aspects of fairness in machine learning, including algorithmic biases, data biases, and the need for transparency in decision-making processes. The authors discuss the importance of fairness in decision-making, highlighting the need for algorithms that are not only accurate but also fair. They emphasize the importance of considering the impact of biases on marginalized groups and the need for mechanisms to mitigate these biases. The papers also explore the concept of fairness in different domains, such as healthcare, education, and employment, emphasizing the need for fairness in decision-making processes.